Hi friends, we are going to mention about integral in this video again. As you remember, one of our previous video mentioning about integral, we reached a result that integral is a special sum, a continuous sum, and it is represented by this kind of sum under limit. And since the partition number of the partition goes to infinity, this discrete sum converted to a continuous sum sign, and this is represented by this syntax. But we couldn't reach an efficient calculation method. As you remember, we made some examples by using this limit, and they took very long. Let's think about a smarter way to calculate the integral. Let's start. Firstly, just think about a function fx, and the integral from 0 to x, a variable x, is equal to ax. I mean, the area here, the area is called as ax. Now we don't know what is the function ax. The ax is just represent the integral of a fixed function from 0 to x. If we find out what is the ax, we can calculate any integral by using this approach. Any integral from a to b, just using the function ax, ab subtract aa, because as you know, from 0 to b, the integrals from 0 to b will be ab, and the integral from 0 to a will be aa, so a of a. So the function, the integral of the function fx from a to b will be b of a and a of a. Let's go on. Again, focus on these figures. Just make a difference of x here, a little difference of x, delta x. As you understand, this little area can be represented by x, a of x plus delta x, and a of x minus a of x, and you may write the area of this rectangle, this little rectangle, but by fx in terms of fx times the delta x. But as you understand, this little difference will occur, and you may write approximately equal fx plus f of x plus delta x times delta x, and a of x plus delta x minus a of x are approximately equal. If delta x is sufficiently small, this approximation will be increased. Let's write this equation, rewrite this equation like that by dividing both sides by delta x, and Let's take the limit of both sides while delta x goes to 0. By this way, you may make the approximately equal sign as equal sign. So please just think for a while, what is the result of this limit and this limit? The result will be fx is equal to derivative of ax. What? Why? Because here the function is independent from delta x, like fx is just in role of a constant according to delta x. So the limit is fx, and here you must remember the definition of derivative. So derivative of a of x. This result says us if we find out the integral of fx from 0 to x, the result is a function whose derivative is fx. So we just found out how we find the ax. After finding the ax, you can easily calculate any integral from a to b of fx dx by ab minus aa. Let's check it on example. You may remember the integral of x square from 1 to 2 by this kind of calculation, and the result 14 over 6 or 7 over 3. We made this calculation in our previous video about integral. Now we learned a new method to calculate this integral. Just find a function whose derivative is x square, which is x cubed over 3, and after finding this function, just make the calculation like this, 7 over 3. This is an important theorem in the calculus, which connecting the two important concepts of the calculus, which are integral and derivative. So for this reason, we call this theorem as fundamental theorem of calculus. And after learning this theorem, we need to learn several ways of finding the functions whose derivative is a function, is a particular function. Thank you for watching.